Welcome to my class. In today's class, I will discuss about some important properties of square numbers. Now, we already have the concept of a square number, and if we have the idea of these important properties, then easily we can identify or evaluate a square number, and also different aspects related to square numbers we can also learn from these properties, which saves time in exam. So let's learn one by one. The first property says a number having 2, 3, 7 or 8 at one's place is never a perfect square. So no square number ends with 2, 3, 7 or 8. Now suppose we know that the square of 2 is 4. If now arbitrarily I choose 7, then square of 7 is 4, 9. So at units place it is 9. Now if I choose 11, then square of 11 is, we know it's 1, 2, 1. So at units place is 1. Now if I choose 25, the square of 25 is 6, 2, 5. So at units place it is 5. Now if I choose suppose 100, then square of 100 will be 10,000. So at units place it is 0. Now in all these examples, if we evaluate that at units place the numbers are 4, 9, 1, 5, 0, but they are not any of this, means 2, 3, 7 or 8. Now square of 4 is 16 and square of 5 is 25. So if I choose a number like 1, 7, which is in between 16 and 25, now if I take square root of 17, definitely that will be between 4 and 5, and that will come in fraction. Now if I choose suppose 18 or 22 or 23, and if I take square root of these numbers, they again will lie between 4 and 5. So we can see here from this example that if at units place, if we have 2, 3, 7 or 8, then that will not be a perfect square. But other than these 4 digits between 0 to 9, we have 6 more digits. So in a square, a number which is a perfect square, then at units place we will have any one of those 6 digits. But that does not always signify that if we have one of these 6 digits, then that number will be always square. No. Now suppose if I take an example 24, and if I take the square root, again that square root, that value will be in between 4 to 5, because we have already seen that 25, square root of 25 is 5. So this is 24, which is less than 25. So it will be less than 5. Now at units place it has 4. So if we go by that concept, that if we have those 6 digits other than these 4 digits between 0 to 9, then that number always will be a perfect square number. No. If the number is a perfect square number, then at units place we will have one of those 6 digits. But a number having one of those 6 digits at units place may not be always a square number. If I take a number 64, and if we take the square root of that, it will be 8. It is an integer. Now another example, if I take say 19, if I take square root, again it will be between 4 to 4 and 5, because it is 19 is between 16 and 25. So if I take the square root, that value will lie between 4 to 5, and it will come in fraction. Now but if I take 49, and if I take the square root, then it will be a perfect an integer, and that value will be 7. So this is what the first property is all about. Now if I move on to the second property, it says that the number of zeros at the end of a perfect square is always even. So a number ending with an odd number of zeros is never a perfect square. So let's understand this with few examples. Now if I take 10, and if I then take the square of 10, it is 100. Fine. Now if I take 20 and if I take the square of that, it will be 400. Now if I take say 50 and then if I take the square, it will be 2500. Now if I take 300 and then if I take the square, then it will be 9, then 0000. So in all these examples, which are the examples of perfect square, we can see here that at the end we have even number of zeros. Okay, fine. Now if I take another set of examples, like if I take 20 and then if I take square root, it will be in between again 4 and 5, because 20 lies between 16 and 25. So when we will take square root, as we have seen in case in the previous property, so it will be between 4 and 5, and that will come in fraction. Now if I take 90, then again it will not be an integer, rather it will be again a fraction, and it will be in between 9 and 10, because 90 is in between 81 and 100, and 81 is the square of 9, 100 is the square of 10. So when we will find the square root of 90, it will lie in between 9 and 10, and that will come in fraction. And now if I take any examples like 16,000, or if I take 9,000 or maybe 17 and then any odd number of zeros after that, then if we find the square root of these numbers, we will see that the square root of all these numbers will again come in fraction, and they will not be integer. So what conclusion we have drawn from here, that in a number, if we have odd number of zeros at the end, then that number will never be a perfect square. A number to be perfect square, it has to have even number of zeros at the end. But again, if a number has even number of zeros at the end, that does not always signify that that number will be a perfect square. Let's, for example, if I take 300, 400, in 400 we have even number of zeros at the end, and if I take square root, then it will be 20. But if I take 300 and then if I take square root, then that will not be an integer. It will be a fraction which will lie between 17 and 18. So I repeat that if a number has even number of zeros at the end, that does not always signify that the number will be always perfect square. But if the number has to be a perfect square, then the criteria is at the end it should have even number of zeros. But if it has odd number of zeros, then that number can never be a perfect square. And that's what this property is all about. Then if we move on to the property number 3, then it says the squares of even numbers are always even numbers, and squares of odd numbers are always odd numbers. And this is pretty simple as it sounds. So if I take 4, which is an even number, then we know the square of that number is 16. If I take 12, then square of that number is 144. If I take 20, then square of that number is 400. Then suppose if I take 18 and if I take square of that, then it will be 324. So all these numbers on the left side are even numbers, and when we evaluate the square of all these numbers, we can find all these numbers as even numbers. We know how to identify, how to evaluate a number, whether it is an even number or not. Now we will take a few examples of odd numbers. Now if I choose 7, the square of 7 is 49, which is also an odd number. If I choose 11, then it will be 121, which is also an odd number. Then if I choose 25, then it will be 625, which is also an odd number. Then if I choose 17 and if I take square, then it will be 289. So what we have seen here, that for of all the odd numbers, if we take square, then the square of those numbers will be again odd numbers. So this is one of the properties that will help us in exam, and this is simple to remember. Now let's see what is the next property. The next property says the square of a natural number. We have already have the idea of natural number. Square of a natural number other than 1 is either a multiple of 3 or multiple of 3 plus 1. Let's understand this property with examples. So other than 1 it is written. So we will start with natural number, say 2. Now if we take square, then it will be 4. So 4 can be further written as 3 plus 1. Fine. Now if I choose arbitrarily 5, then it will be 25. So 25 can be further written as 24 plus 1, and 24 we know it is 3 8s are 24, then plus 1. Then now arbitrarily if I choose 11, then it will be 121. So 121 is what? 120 plus 1. And 120 is what? 3 40s are 120 and then plus 1. Fine. Then if I choose 18 and if I take square, then it is 3 2 4. 3 2 4, 4 plus 2 6 plus 3 9. 9 is a multiple of 3, that means it will be multiple of 3 and it will be 3 multiplied by 108. And now if I take an example like 30, then it will be 900. 900 again it is 3 multiplied by 300. So what pattern we have seen here? We have noticed here that 2 square. So it is multiple of 3 plus 1. 5 square. 25. Finally 3 multiplied by 8 plus 1. 11. It is 121. Finally it is 3 multiplied by 40, then again plus 1. And all these numbers 2 5 11, they are not, these numbers are not multiple of 3. So when we are taking square of those numbers, square numbers will be multiple of 3 plus 1. And when we are taking square of the numbers which themselves are multiple of 3, then the square of those numbers will be also multiple of 3, and that is obvious. And that's what we have seen here. 18 square, when we are taking 18 itself is multiple of 3. So when we are taking the square of that number, it is also coming as multiple of 3. Similarly, it is happening with 30. 30 itself is a multiple of 3. 30. So when we are evaluating the square of 30, we are also getting that it is a multiple of 3. So any square number will be either multiple of 3 or multiple of 3 plus 1. And when it is multiple of 3, when the number itself is multiple of 3, the square will be also multiple of 3. If the number is not a multiple of 3, then the square will be multiple of 3 plus 1. But this rule we cannot apply in case of 1. Other than 1, this is applicable for any natural number. And the next property is also similar to this one. It says the square of a natural number other than 1, again other than 1, is either a multiple of 4 or multiple of 4 plus 1. Now again, if I take example 2, then square of 2 is 4. So 4 itself is again it's 4, so multiple of 4 only. Then if I choose suppose 6, so it is 36. So it can be written as 4 9s are 36. Now if I choose 7, then it will be 49. So 49 means 4 12s are 48, then plus 1. Now if I take 9, then it will be 81. 81 means what? 4 20s are 80, then plus 1. Fine. Then if I take suppose 18, then 18 means 3 2 4. So 3 2 4 can be further written as 4, then it will be 81. So it is a multiple of 4. Now if I choose suppose 25, then 25 square of 25 will be 625. So it can be written as 4 multiplied by 156 plus 1. So here what we have noticed is square of any natural number other than 1 is either it is multiple of 4. So here it is multiple of 4, here it is multiple of 4, then again it is multiple of 4, or it is multiple of 4 plus 1. So all these numbers are multiple of 4 plus 1. And another pattern we have noticed here, that when the numbers are even numbers, then square of those numbers are coming as multiple of 4. And when those numbers are odd numbers, then the square of those numbers are coming as multiple of 4 plus 1. That is obvious, because if they are odd numbers, then we have already seen that the square of odd numbers will be odd numbers only. So odd numbers can never be multiple of 4. So though they will be multiple of 4 plus 1. So this is again one of the important properties of square numbers. Next we will learn another property, and that says the units digit of the square of a natural number. So first we will choose a natural number like 5. If we choose, then square of that natural number is what? 25. And what is the unit digit? Units digit or digit at units place or ones place, that is 5. Okay. So units digit of the square of a natural number is units digit of the square of the digit at units place of the given natural number. It sounds a bit confusing. So till this we have already we have seen that the units digit of the square of a natural number. So natural number we have chosen 5. We have taken the square of that, and that is 25, and the digit at units place is 5, and that will be equal to what? Let's see that. Units digit of the square of the digit at units place of the natural number. So natural number is what? 5. And again it is, since it is a single digit number, so at units place it will be 5 only, and the square of that 5 will be 25, and at units place it will be 5 only. So we will not properly understand this property with a single digit number. To understand this property in a better way, let's choose a 2-digit number. So if suppose if it is 25, then square of 25 is what? 625. Now come to the point. So units digit of the square of the natural number. So what is the units digit or digit at units place of the square of the natural number? It is 5. Now this is the right hand. This is coming from the right hand side, and from the left hand side what we are getting is of the given natural number, means 25, digit at units place. So from the given natural number, if we fetch the digit at units place, then it is 5 only. And then what we have to do is square of that digit. So it will be 25. And now if we assess the digit at units place of this square, then it will be 5. So these two digits at units place will be equal. That's what this property says. Let's understand this with another example. Say if we choose 11, then if I take square, so it is 121. So what is the digit at units place of that square? 1. Now from the given natural number, if I take the digit from the units place, then it is 1 only. And now if I take square of that 1 or that digit which was at units place, then it will be 1 only, and this digit should be equal to the digit at units place of the square number. That's what it says. Now if suppose if I choose say 40, so 40 means it will be 16, then 0, 0. So now what is the digit at units place? It is 0. And now if I take the digit at units place from that natural number, then it is 0. So 0 square of 0 is 0. So this digit should match with the digit at units place of the square number. Now another example, if we choose 17, say 17 square means we know it is 289. So what is the digit at units place of that square number? It is 9. Now if I take the digit at units place of that natural number, then it is 7. So 7, now if I take the square of 7, it will be 49. So what is the digit at units place of this square? It is 9. So this 9 or this digit and this digit should match, and this is what this property says. Now we will move on to the next property. It says that there are no two natural numbers p and q where p and q are any true arbitrary natural numbers, and these two numbers can never hold this relationship where p square will be 2q square, and this is true for any of these combinations. And what are these combinations? P and q, I said that these two have been chosen arbitrarily. These are two arbitrary number in the number system. Now when p and q both are odd, then also this is not true, and similarly this is also not true when p is odd, q is even, p is even, q is odd, and when both are even. So let's understand this with one example for each category. So when p and q both are odd, suppose the two arbitrarily chosen numbers are 3 and 7. So this is our p, the first number will be always our p and second number will be q. So if I take square of 3, that will be 9, and if I take square of 7, then that will be 49, and 2 multiplied by 49, that will not be equal to 9. And now if I interchange p and q, suppose if I choose p as 7, then if it will be 49 p square, and if I choose q as 3, then it will be q square will be 9, and when we will multiply 9 with 2 or by 2, it will be 18. So 49 is not equal to 18. Now for the second case, if we choose to p is odd and q is even, so p is odd, suppose p is 5 and q is suppose 4. So 5 square means 25, 4 square means 16, and multiplied by 2, it will be 32. 25 is not equal to 32. Now suppose p is 5 and q we are choosing greater than 5. So p square of p means 25, and now q if we choose as suppose 8, so it will be 64. 64, and if we multiply by 2, it cannot be equal, they are not equal. And since it is 2q square, so we will not choose further q which will be greater than p, because if we choose q which will be greater than p, then obviously 2q square will be greater than p square only, that will never be equal. So we will further choose p greater than q. Now in the third case, p is even and q is odd. So p is even, suppose if we choose 10 p, then 10 square means 100, and if we choose q less than p, then suppose if it is 3, then it will be what? 3 square means 9, and when we will multiply by 2, it will be only 18. 100 is not equal to 18. Now if I choose suppose 7, so it will be again 100 on the left side, p square, and q square means 49. 49 when we will multiply, it will be 98. Again, though it is very close to 100, but still it is not equal to 100, so it doesn't satisfy this condition, this relationship. Now for number 4, if we choose p and q both even, then suppose p is 12 and suppose q is 8. So p square will be how much? P square will be 144, and q square will be 64, and then when we will multiply 64 by 2, it will be 128. 128 is not equal to 144. So what we have seen here, that whether they are even, odd, or whatever is the combination, for any two arbitrarily chosen natural numbers, this relationship will never be true. Now we will move on to the next property. For any natural number n, n plus 1 square minus n square will be equal to n plus 1 plus n. And this is very interesting and this is very easy to remember. So what it says is the difference of square of two consecutive natural numbers is equal to their sum. So first we will choose a natural number which is 3. So here n is equal to 3. And then the next natural number, the consecutive natural number, so it will be 3 plus 1 means 4. So it will be first 4 square and then minus 3 square, n plus 1 square minus n square. So how much it will be? It will be 16 minus 9, so it will be 7. And 7 can be further written as 3 plus 1 then plus 3. So 3 plus 1 is what? 3 plus 1 is n plus 1, because we have already chosen n as 3. So it is n plus 1 and then plus this is n. And this is what? This is n plus 1 square minus n square. And this is true for any two consecutive natural numbers. Now let's choose n is equal to, let's 5. So it will be 5, and then next natural number is 6. So what we will do, first we will take the square of 6, which is 36, and then from there we will subtract the square of 5, which is 25. So it will be how much? It will be 11, and 11 can be further written as 5 plus 1 and then 5. So what it is? It is n plus 1 and then plus n. So now if I choose n is equal to 11, suppose, or let's choose n as an even number, say n is 10. So 10, the next natural number will be 11. So first we will take the square of 11, which is 121. Then we will take square of 10, which is 100. So what is the result of subtraction? 21. And 21 is what? 11 plus 10. So 11 is what? 10 plus 1, then plus 10. So again it is n plus 1 plus n. So this is very easy, and this is very important and interesting as well. Now the next property says the square of a natural number n is equal to the sum of first n odd natural numbers. Let's choose a natural number 6. So square of 6 is how much? It is 36. Okay. Now what it says, square of a natural number is equal to the sum of first n odd natural numbers. So it will be first 6 odd natural numbers. So first 6 odd natural numbers means first odd natural number is 1, then it will be 3, then it will be added with 5, then 7, then 9, and then 11. So 11 plus 9, 20, 27, then 32, 35, 36, and this is what this property says. Now the next, if we choose say 11, so 11 means it will be 121, and it will be 121 can be further written as 1 plus 3 plus 5 plus 7, then finally plus 21. So here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11, first 11 odd natural numbers. Now if we add all these odd natural numbers, we will be getting this value only, 1 to 1. Now we can verify this property with any natural number. So this is also very interesting, we can say. Now the next property says that for any natural number n greater than 1, 2n, n square minus 1 and n square plus 1 is a Pythagorean triplet. So what is the Pythagorean formula? We know that. Now here we will see the Pythagorean triplet in case of natural numbers. So but it will not be applicable in case of 1. So other than 1 we will apply. So let's choose the next natural number after 1, and that is 2. So 2 means we will take one number as the double of that natural number. So it will be 4. Then the next natural number will be 2 square minus 1. So 4 minus 1, which is 3. And then the third number will be, it will be n square plus 1. So 2 square plus 1, that means 5. And between 4, 3, 5, we have the Pythagorean relationship, and that is if we take the square of 5, then it will be 25. 25 can be further written as 16 plus 9, and 16 is what? 16 is 4 square, then and 9 is 3 square. So it will be 5 square will be equal to 4 square plus 3 square. And this is what the Pythagorean triplet is. Now if I choose suppose 5, the natural number, then 5, so 2n, so it will be 10. Then it is n square minus 1. N square minus 1 means 25. Square of 5 is 25. 25 minus 1 is 24. And then 5 square plus 1. So it will be 26. And now if we take the square of 26, it will be 676, and 676 further can be written as 576 plus 100. And 576 is what? 576 is square of 24, and 100 is square of 10. So between 10, 24 and 26 we have again this Pythagorean triplet or this relationship. So this is also very interesting and important, and the properties that we have learned in this class, if we can remember all these properties, then they are proved very useful when we deal with square numbers, and they also help us to save time in exam. I hope this class was meaningful to you and you have learned something new. With this, I end today's class. Thank you.